How's it going, guys? It's Tommy. We're going to be simplifying exponents in this episode, and this is going to bring together all of these rules. Now, I made a video already for each one of these rules. We have a video on the power rule, negative exponent rule, product rule, and quotient rule. So review those first, and if you already have, let's dive right in. You're going to get simplify something like this. In this case, we have 4x squared, y cubed squared, and then 2xy to the fourth, all that cubed. Well, these are the steps in which we attack these problems. So we have to follow these rules in order. This is almost like our order of operations for exponents. So the first step is our power rule, which meant that when we have a power to the power, we multiply our exponents. So let's rewrite the problem. We're going to have 4 squared x raised to the 2 times 2 y to the 3 times 2. Okay? All right, and then down below, we're going to have 2 cubed x. There was a 1 right here, right? So we're going to have 1 times 3, and then y to the 4 times 3. Okay. So let's simplify that. We'll have 4 squared. Well, that's 16. Oh, I'm sorry. First of all, step 2 is the negative exponent rule. We're not going to have any negative exponents here, so we're good. 16 x to the 4, y to the 6. All of that divided by 2 cubed. Well, 2 cubed is 8, so we're going to have 8. X to the 1 times 3. 1 times 3, it's 3. And then y raised to the 4 times 3. That's 12. Alrighty. So now, like I said, we don't have any negative exponents here, so we can skip the negative exponent rule for now. Step 3 is the product and the quotient rule. Well, what are we doing to these two terms here? We're just dividing them so that we need to set up the quotient rule. Well, we learned from the quotient rule that anytime we're dividing exponents, we just subtract. So let's rewrite this. We're going to have 16, well, I guess we'll technically be 16 over 8. That'll be on the outside. Just bring it out. And then x to the 4 minus 3, y to the 12 minus 6. No, I'm sorry. Numerator goes first, right? 6 minus 12. Alrighty. So let's go ahead and simplify this out. We're going to get 16 over 8. Well, that's 2. X to the 4 minus 3. Well, 4 minus 3 is 1, which is imaginary. And then y to the 6 minus 12 is y to the negative 6. Now this is where I say we kind of have to bring back maybe that negative exponent rule, because while this is correct, we don't want to leave it like that. So 2 times x is just 2x, and then remember, to make this positive, we just move it to the denominator. So it's 2x, y to the 6th. That's it for that one. Let's go ahead and do one more. All right, now for these, because the problems are long and I don't want you to go to sleep, I'm just going to do one more example. So we're going to simplify 3xy squared, square that, 2y cubed z squared, cubed, all that divided by xy to the 6 z squared, squared. Whew, that's gross. Well, just take it slow, follow these steps. You can all do this. So we're going to simplify, let's rewrite, we're going to do the power rule. So we've got 3 squared x, to the 1 times 2, y to the 2 times 2, power rule, right? Okay, and that is all multiplied by 2 cubed, y to the 3 times 3, z to the 2 times 3. All right, taking it nice and slow. And then our denominator for all this is going to be 8 squared x to the 1 times 2, y to the 6 times 2, z to the 2 times 2. All right, well, that's disgusting, so let's go ahead and rewrite it. 3 squared is 9. X, or the 1 times 2 is x squared. 2 times 2 here is y to the 4. All that is multiplied by 2 cubed, that's going to be 8. Y to the 3 times 3, so y9. z to the 2 times 3, so z6. All that divided by 8 squared is 64. X to the 1 times 2 is going to be x squared. Y to the 6 times 2 is y to the 12. 2 to the 2 times z to the 2 times 2 is z to the 4. All right, cool. So now we have to somehow make sure we got to incorporate these two, right? This is going to be a product rule. So we need to combine these, and then we can do the quotient rule. Well, so this is going to be rewritten as, we do have 9 times 8, so that's 72. X to the 2, and there's no x over here, so it's going to stay x to the 2. Now we got our y's, right? And for the product rule, we're going to add these together. So we have y to the 4 plus 9, and then there's no other z's, so it's just z to the 6. All right, so let's simplify this because the denominator is going to stay the same, and then we can do the quotient rule. So we'll have 72. So we have 72 x squared, y to the 13, z to the 6, and all that's going to be divided by our old numerator, so 64 x squared, y to the 12, z to the 4. All right, gross. So for our last step, we just need to do the quotient rule and then resimplify. By the way, this is step 3. All right. We're going to have 72 over 64. And like I said, you just kind of pull the numbers out and separate it from the variables. You can always just kind of come back to it in a second. So now we're going to have x to the 2 minus 2, right? 2 minus 2. Y, numerator minus denominator. Z to the 6 minus 4. And that's just subtraction, right? So just bring it all together now. So we're going to have x raised to the 0. And anything raised to the 0 is 1. So this is just going to go away here in a second. All right, y to the 1. Z to the 2. And 72 over 64, well, greatest common factor for these guys. Let's see here. I think we can only just reduce this down to 9 over 8. Yeah. So if you divide both of these by 8, 72 divided by 8, so we'll just do 8. This becomes 9 over 8. X to the 0 was just 1, so we're just going to leave that like it's not even there. So y to the 1, z squared. And that's it for that long, ugly problem, but I guarantee if you can do this one, I don't see a teacher that's going to put anything on there, uglier than this, unless they wanted to throw fractions in there. But I'd say you guys are good. If you need any review, please let me know. If you want more examples like this, just comment, hey, please work more examples, and I will. Thanks for watching.